Hello and welcome to yet another video of Cornerstones of Math. Today I've got this really nice limit problem which utilizes many important limit related knowledge. The problem is, when a is positive and a is not equal to 1, we want to find the limit of a to the power of x minus 1 times ln 1 plus x divided by e to the power of x minus 1 log base a of 1 plus x. And I already have two things to say about this problem before getting to the actual solution. First, I will show you two methods in this video. Second, some of you may have already realized that this is 0 over 0 type indeterminate limit. One powerful tool for such limits is the famous L'Hopital's rule. However, as for this problem, using L'Hopital's rule right away will not give you a satisfying result. I mean, the derivative formulas for exponential and logarithmic functions are pretty familiar to many people. Therefore, applying the L'Hopital's rule itself is not a problem. The problem is that the resulting limit is still in 0 over 0 form, now with much more complicated expressions on both numerator and denominator. Therefore, we must approach this limit a little more smartly. In the first method, I am still going to use the L'Hopital's rule, but in a smarter way. First, let us write this limit as the product of two limits. Limit of a to the power of x minus 1 divided by e to the power of x minus 1 times the limit of ln 1 plus x divided by log base a of 1 plus x. We can split the limit like this if both limits on the right hand side exist, and I am going to show you that both limits indeed exist. The limits on the right hand side now can be evaluated using the L'Hopital's rule. So the first limit of a to the power of x minus 1 divided by e to the power of x minus 1 is equal to the limit of a to the power of x ln a divided by e to the power of x by L'Hopital's rule, which simply gives ln a. And the second limit, the limit of ln 1 plus x divided by log base a of 1 plus x is equal to the limit of 1 over 1 plus x divided by 1 over 1 plus x ln a, which gives ln a. Therefore, this limit is ln a times ln a, which is equal to ln a squared. A quick side note here. In this method, I split the limit like this. But you can also use the same L'Hopital method when you split the limit as limit of a to the power of x minus 1 divided by log base a of 1 plus x and the limit of ln 1 plus x divided by e to the power of x minus 1. If you apply the L'Hopital's rule here, the first one gives a to the power of x ln a divided by 1 over 1 plus x ln a, and the second one gives 1 over 1 plus x divided by e to the power of x. So the first limit gives ln a squared and the second limit gives 1. So we obtain ln a squared. So we arrive at the same answer. But now it's time for the non-L'Hopital method. In the second method, I am not going to use the L'Hopital's rule, but instead I am going to use the so-called limit definition of the constant e. That is, the limit of 1 plus x to the power of 1 over x as x approaches 0 is equal to e. And we can derive so many useful limits with this as the starting point. If we take natural logarithm on this limit, then we obtain limit of ln 1 plus x over x as x approaches 0 is equal to 1. Moreover, let ln 1 plus x equals t. Then 1 plus x equals e to the power of t, hence x equals e to the power of t minus 1. And as x approaches 0, t approaches 0 as well. Therefore, the limit above becomes limit of t divided by e to the power of t minus 1 as t approaches 0 is equal to 1. Now, what about limits with general logarithm log base a of 1 plus x and general exponent a to the power of t? Well, as for the logarithm, we use the famous base change formula to change the base into e. That is, we change into natural logarithm. Since log base a of 1 plus x is equal to ln 1 plus x divided by ln a, we have the limit of ln 1 plus x divided by x times ln a, and using this previous result that this part goes to 1, we have 1 over ln a. Now, as for the limit of t over a to the power of t minus 1, you can use the similar method as this, but now with log base a of 1 plus x as t, or you can use the fact that this a to the power of t can be expressed as, since we can express a as e to the power of ln a, we have this to the power of t, hence e to the power of t ln a. Then we have the limit of the denominator becomes e to the power of t ln a minus 1. Here, since this t ln a part also goes to 0, we split into t ln a divided by e to the power of t ln a minus 1 and 1 over ln a, and this part goes to 1 because of this previous result. So we have 1 over ln a. Therefore, if we apply these properties to our problem, we have, first, we write the function as x divided by e to the power of x minus 1 here, then x divided by log base a of 1 plus x here, then x divided by a to the power of x minus 1 here, and then x divided by ln 1 plus x here. Then, on the numerator, we have 1 times ln a, and in the denominator, we have 1 over ln a times 1. So we obtain ln a squared. And that's all for today's video. Thank you for watching. Please don't forget to hit the like and subscribe buttons if you enjoyed this video, and I will see you in another video.